Hi there, and welcome to this video on rotational symmetry. We're going to talk through the idea of rotational symmetry and have a look at how to find the order of rotational symmetry of certain shapes. The order of rotational symmetry refers to how many times a shape would look like itself during a 360-degree rotation around its center. So if I was to rotate this equilateral triangle 360 degrees, how many times would it look exactly the same? Let's have a little look. Once, twice, and then back to its original position, 3. So this equilateral triangle has an order 3, an order of rotational symmetry 3. During a 360-degree rotation, this shape looks like itself 3 times. And the yellow dot helps us visualize that during the rotation. If we move over and have a look at the parallelogram, again, I've included the yellow dot so we can visualize the rotation. I'm going to rotate the parallelogram 360 degrees around its center, and we'll take notice of how many times it looks like the exact same shape. Once and twice back to the original shape. So a parallelogram, this one in particular, has order 2, order of rotational symmetry 2. During a 360-degree rotation, this shape looks like itself 2 times. If we have a look at the kite, again, the yellow dot is there to help us visualize. I'm going to go ahead and rotate this kite 360 degrees around its center. And once back in the original position. So with this shape in particular, we rotated the shape 360 degrees and it only looked like itself on one occasion, and that was the original position of the shape. So for this shape, we would state that it has order of rotational symmetry 1. You may also hear this sort of shape referred to as having no rotational symmetry. So if the shape rotates 360 degrees and only looks like itself as the original shape, we would state that it has order 1 or that it has no rotational symmetry. So therefore, all shapes, no matter how complex or abstract, will always have at least order 1 for rotational symmetry, because of course they will all look like the original shape at one point in the rotation. If we move on to D, we can probably make a prediction as to the order of rotational symmetry of this hexagon. Once, twice, 3 times, 4, 5, and back to the original position, 6. So this hexagon has order 6, order of rotational symmetry 6. If we move over to E, this flower pattern, again, we're going to go ahead and rotate it 360 degrees around its center. So we could imagine placing a sharp pencil here or a pin here and rotating the shape 360 degrees. Once, twice, 3 times, and 4 times. So this shape, as you may have already guessed, has an order of rotational symmetry 4. We'll do the same for F. We're going to rotate the shape 360 degrees. 1, 2, 3, 4, and back to the original position 5. So order of rotational symmetry for this shape here. You will notice that the regular shapes, the equilateral triangle, the regular hexagon, and this is a regular pentagon, the amount of sides that those regular shapes have corresponds exactly to its order of rotational symmetry. So if we had a regular octagon, an 8-sided shape, we would be expecting an order of rotational symmetry 8. Okay, so what I want you to do at this point is I just want you to look at each shape on the screen, visualize that rotation that we just looked through on the previous slide, and think about the order of rotational symmetry that each shape would have. So for all 12 questions, could you identify the order of rotational symmetry? You may want to pause the video at this point as you have a think about all 12 questions. Okay, welcome back. We'll just talk through some of the answers. For question 1, we have an order 6. For question 2, we have an order 2. Notice that when we're dealing with colors or shading within patterns and shapes, that also impacts on the order of rotational symmetry. So if the black section was to land here, that would not look like the original shape. Order 3, order 2. Question 5 has order 1, no rotational symmetry. If we rotated it 360 degrees, it would only look like itself in the original position, so we state order 1. Order 3 for number 6. 7 gives me order 2. For number 8, order 5. For number 9, order 4. For number 10, again, we're dealing with order 1. Because of the nature of the color and the pattern, during the rotation, it will only look like itself as the original shape. 11, order 6, and 12, order 8. As discussed as we left the previous slide, a regular octagon, you would expect to have order 8 because it has 8 sides of the same length. Okay, same task in front of us again. I would like you to pause the video and just visualize each rotation, identifying the order of rotation for each shape. Could you pause the video now, please? Okay, welcome back. For number 1, we have order 4. For number 2, order 1. Number 3, order 2. Order 5, order 2, order 4, order 6, order 3, equilateral triangle again. So because we have 3 equaling sides, we're expecting an order of rotational symmetry of 3. Order 5, order 4, order 3, and order 1. So again, number 12, no rotational symmetry, order 1, because the nature of the pattern, the nature of this white square in the top left corner, as we rotate that 360 degrees, it will only look like itself once that small white square returns to the top left corner. Okay, here's a task I would like you to have a go at. What I would like you to do is think about all the letters of the alphabet as capital letters, so as displayed on the screen now. We should be aware that all of the shapes will have at least order 1 for rotational symmetry. But what I want you to do is identify those letters which would have more than 1 for their order of rotational symmetry. So I'd like you to pause the video at this point. I'd like you to work through this task and identify all the letters which have order of rotational symmetry greater than 1. Could you give this a go now, please? Okay, welcome back. So I'll just talk through those letters. When displayed as capital letters, that would have an order greater than 1. So we have the letter H. If we rotate the letter H, it will look like itself when it is upside down and when it is the original shape. So therefore has an order 2. The capital letter I, if we rotated it, it would look like itself when it was upside down, giving it an order 2 as well. The letter N, if we rotated it 360 degrees, you can see at this point it would look like the original N, also giving it order 2. For O, as we rotated it upside down, it would look like itself. So again, giving it order 2. That is for the capital letter O. If, of course, it was a perfect circle, then we would have quite a unique answer in that a circle would have an infinite amount of order of rotational symmetry. But because we're dealing with a capital letter O, which is slightly elongated, then that order 2 is correct. But a perfect circle would have an infinity amount of order of rotational symmetry. We also have the letter S. Once rotated upside down, looks like itself, so we're dealing with an order 2 again. The letter X, also order 2. And then finally, the letter Z, also order 2. So very well done if you were able to identify those 7 letters as having more than order 1 for their rotational symmetry. Here we have a few more examples of rotational symmetry. You'll see from the snowflake in the top left and the snowflake in the center at the bottom that they both are displaying order rotational symmetry 6. They are both snowflakes that have fell from the sky and they've been placed under a microscope, and you can see that their structure follows the idea of a hexagon, 6-sided shape. So because of that, each individual snowflake, although it shows a very unique pattern, will always have order 6 for its rotational symmetry. We can also see where rotational symmetry occurs in nature. We have a starfish here displaying order of rotational symmetry 5. We are aware that rotational symmetry occurs in mathematics. Over here we have a recycling symbol that is used on a lot of products in marketing and advertising. And again, you can see the use of rotational symmetry. It makes the logo very eye-catching, very pleasing on the eye. So rotational symmetry is often used in marketing and displaying and presenting things in an attractive way. We also have rotational symmetry here in what could be a tattoo or artwork. So again, a lot of tattoo artists will deal with rotational symmetry again, just to make the image look very eye-catching and pleasing, as discussed about the recycling symbol. Okay, so this is your next task. I'd like you to have a go at finding the order of rotational symmetry for all of the shapes displayed on the screen. Could you have a go now, please? Okay, welcome back. Okay, you can see the answers displayed on the screen now. Just very quickly talking about this shape here, at first glance you may have thought it was order 4, but once we take into account these sides, which have this curved line on both sides, that does in fact mean we're dealing with an order of rotational symmetry 2. Down here we have a kite, order of rotational symmetry 1. It only looks like itself on one occasion. We could state that it has no rotational symmetry, order 1. 9 more shapes and patterns to have a go at. For each one, could you tell me its order of rotational symmetry? Welcome back. I've displayed my answers on the screen now. Remember to take into account the shading or color within a pattern or image. So at first glance, you may have thought this would be order of rotational symmetry 6, but because of the alternate gray and white pattern, we're actually dealing with an order 3. Very well done if you got all 9 correct there. Okay, so now we're going to have a go at a challenging task. For each question, if you could draw out on squared paper or triangular paper the original image and pattern that I'm presenting on the screen. Once you have copied down the original question, I want you to add on shaded squares to each pattern to make sure that the shapes have the correct order when rotated around this black dot. So you need to copy out the original question as it stands, and then you need to make the shape have the correct order of rotational symmetry by adding shaded squares. This is quite a challenging task, so you may need to try and visualize what you are rotating, and you may use tracing paper to help you if you require it. Could you pause the video at this point, and then I'll show you my solutions when you unpause the video. Okay, welcome back. So my answers to this task. So hopefully you were able to draw out the original question, which is the grade squares or the grade triangles, and then you're adding your own shaded shapes. I've added it in red, so it stands out and it's easy for you to see. You may have used tracing paper to help you get your accurate answers, but now you will see that in each box, all of the shaded shapes, whether squares or triangles, they go together to ensure that the orders are correct. So this shape here now displays order of rotational symmetry 6. This shape now, after I've shaded in these red squares, shows order of rotational symmetry 2. That is a very challenging task, so very well done if you were able to answer those questions correctly. In particular, the 3 questions at the bottom of the screen. If you're able to answer all 9 correct, that's brilliant. You've shown a good understanding of rotational symmetry.